So we were just talking about like EPS systems. I saw that you did a little bit of work on there.
Oh yeah, definitely. I'm probably gonna need Andrew and Isabel anyone's help on that. From my knowledge, those are the go-to ones for the protection one. I'm kind of like unsure because I feel like the one that two of them are for when you design your own PCB, and I got the Adafruit one, which I think will work better for a mission. Should I be showing this or
Oh,
like
if you
or
want to.
okay? I mean, okay, give me like 2 secs. Uh,
I don't know, like would we need multiple OBCs?
I don't think we would need multiple OBCs, but we can always, yeah, we can add on if we want to. We have, to be honest, the components looks pretty. I don't want to jinx us, but it's pretty cheap. Like we're gonna be under budget. Looks like it.
No, that's a good thing.
Yeah,
I
so we
think
can always
that's
add on.
the more, well, I mean, the less cost, or I guess the more cheap it is, the better.
Yeah, that's true.
Yeah.
Can you allow participant screen sharing?
Oh yeah.
Should I go from the top or just go on EPS?
Just do EPS.
Okay. I guess well technically everything's EPS on here, but
Well, yeah, no. Oh, I mean OBC. My bad.
oh OBC. Let's
Yeah,
start
yeah.
with OBC. All right.
Hey.
So am I good to start?
Oh yeah, go ahead. Yeah.
Okay, so I looked at these three. The Arduino Nano and the Uno were like our first ones, and the reason red means that it's absolutely no, yellow means maybe, and green means I think this might be the best one. There's only two of these, but the other ones are I'm not sure to be honest. The reason why the Arduino Uno R3 is red because it does the same exact function as the Nano, but the Nano does what the Uno does better and it's bigger. The reason why the Uno is like so sought after is because it's user friendly, I guess, and it has a little functions on the board itself that makes it more usable than the Nano. But the Nano basically does what the Uno does, but a little more. And the Raspberry Pi, the reason I chose the Raspberry Pi over the Nano is feel free to jump in at anyone at any time if you think something might be better. It's because its SRAM is 264 kilobytes, while the Nano is only 2 kilobytes. That means it can do everything a little bit faster. I'm not sure that's too essential, but also this costs $20 and this only costs $5.
Big
The downside
difference.
of this one is that this is slightly bigger, but it's like three one way and six another. I don't think it's too big of a deal. Same input voltage. Input voltage is what you need to put in for it to run. Might be wrong on that, and it's a little bit less than what the Nano requires. The operating temperature I couldn't find on the Nano, but I'm gonna assume it's probably -20, -40, same as the Pico. And building off from this, it has a better processor, 133 millihertz compared to what was it? Can't find it.
It's cool.
I don't
Oh, it's
remember. I don't remember, but it's in the
oh,
like.
it's down there. It's on cons on the
Oh yeah,
bottom.
16. There you go. And going off from this, it has more pins. Okay, so it
Oh,
has
allow for more
34.
connections.
Yeah, it has 34 compared to 30, I believe. And the power consumption, I couldn't find it on the Pico, but I'm gonna say it's probably the same. I'm not too sure to be honest. And what really sold this was it had a temperature sensor as well, so we can get data from it if we want to.
Did you ever find like what its bit rate was?
The bit rate? What do you
Hmm.
mean? No, I didn't look at the bit rate, but I can look at it later if you want.
I don't think. I think honestly, the Pico would be fine for now.
Yeah, there's still links on to each one of them for each of the slides, so you guys want to look at it.
Cool.
And feel free to add on if you guys think there's like, oh, I think this microcontroller can be better than the Pico or the whatever.
Yeah, I definitely agree. The Arduino Uno is very friendly. Like, because I use it kind of from time to time when I'm doing like little small things. But if it's definitely better than the Nano or the Pico, we'll just definitely disregard that. Yeah, I think if you think the Pico is better, then like I think we should just go with that for right now. And then like if we need to switch it, then we can switch it.
What does everyone else think as well?
Yeah. That's just my opinion.
I just noticed that on the Raspberry Pi Pico. So I searched it up and it says it doesn't have like a 5-volt output. So I don't know if we need that.
That's a good catch. Yeah.
While like the two Arduinos have that.
Ooh. Okay. So it's basically if we want to do things faster, or do we want more?
But we probably need to look at like what needs our 5 volts output.
Yeah, definitely.
Yeah. If there's no like 5 volts output requirement, then we could just go for the Pico.
All right. Anybody else, or are we good to go forward? Oh, 5 volts. All right. So here's the batteries with them on this. The ion part just means that it's just basically rechargeable. These are the three, and the reason I chose these three, there's no particular reason. There's a reason for this one. This is what's used on Bronco Sat, this model. It's not the exact, it might be the exact one, I'll be honest. I think this might be the exact one. But anyways, the other two brands seem reliable to me, and they had really good specs. So if you look at all the nominal capacity means how much I can output basically. It's all the same except this Panasonic one had 50 more. I'm not sure how significant that 50 is. If anyone knows, feel free to shout out. And even though this has a less continuous discharge rating, which is only 8 amps compared to the 10 on other ones, I don't think it's really like, what's the word, meaningful to our mission, because that's it has a shorter lifetime, but it's not like, what's the word? Lifetime, I think, if I'm reading this right, 8 amps means how much it can output, like 8 amps in total, and this is milliamps, right? And I'm not sure how much milliamps are in amps, but I don't think it's
very, very small.
Yeah, very small comparison. Yeah, so I don't think this matters. Feel free to jump in if I'm completely off. The nominal voltage are all the same, except this says 3.7. That's not a big difference.
No.
Okay, so the why these two are highlighted as yellow compared to this one is that it's the weight, 847.5 compared to 33.5, and we're gonna need more than one of these bad boys. The con is that this costs $1 more, but like, it's not too much, I guess. But yeah. So it's between these two. I'm not sure. If anyone wants to give it a shout, I like this one better because feel free.
Like it's been like flight tested. Or I wouldn't say flight tested. Because Bronco Sat hasn't been launched
yet. Yeah, there must be a reason why they chose this one. I don't know. I can ask around. But yeah.
I mean, it looks like the Sanyo and the Panasonic are basically identical.
Yeah, they're basically identical, except is 50 milliamps like a big deal? Like, do we need an extra 50? I mean, it'd be nice, but like, is it necessary?
If I was electrical, I would definitely let you know, but I'm mechanical, so I'm not sure. But I would probably say not really, no.
Yeah, not really. I mean, it's really small. It's
very, very
microamps.
I mean, the big thing there is the weight, though, right? Because I mean, batteries, let's just say, I mean, the one on the right is almost 2/3 of the weight of the Panasonic one.
That's true.
And that's going to add up quick. And I mean, for the extra $1, I mean, you're paying $3 extra for maybe a good, what is it, like 60 grams less, adding up later.
That's a good point.
I mean, just like if there is no difference with the milliamps, like in the long run, they're basically the same thing. Like looking at the stats, or sorry, the specs. I mean, they're essentially the same thing, but like it's a good almost 15 grams less. And do you know how many it's going to like need? I mean, you said we're going to need more than one, right? Like an estimate.
Yeah, probably like 3 or something.
So that's already like 45 grams right there.
Yeah, and for like, I guess, realism-wise, 1 gram is, 1 pound is 400 something grams, 450 grams. So yeah, and then like it's like we have to be under 1.3 kilograms, which is about, I think, 3 pounds or something.
So do we like the Saniel better then?
I mean, it either way. Honestly, they seem like the same thing, and in the end, those 45 grams may not even matter too.
Yeah.
Just as like the 50 milliamps don't matter, but it's just an interesting thing. Like, what do we value later?
I have a question, but this probably is going to pertain to later. But these tops on these batteries are different. How is that going to work with a battery board? Because I could not find any battery boards. Like I couldn't find it. So
Couldn't find any battery ports.
yeah, like I searched
Serious?
out lithium-ion battery boards and nothing pops up. So I'm not sure. So do you guys have any input? Like which top is better?
I mean, I don't know if that even really matters. Because, I mean, basically, how I see it is you just have to have a specific board on it, and you basically just have to put the in batteries in. Like, if you were to have like a controller, you just place them in there. That's it. I know. Yeah. I hope that makes sense.
Yeah, that makes sense. I was just wondering because like I thought the tops was something special because the Saniels have like so many different different tops. It's like why did I use that?
I don't know, but we could probably keep that in the back of our heads. But I think I'm kind of leaning towards part of the Samuel one. Yeah, that's just me though.
Okay. Does everyone think the Saniel might be better or?
We'll just call it a maybe for right now.
And maybe. Okay, I'm gonna keep it as yellow. Okay, and okay, so the EPS heat solution. Okay, so this was the one that Zach suggested, the hand warmer. Look at it. Yeah, it looks it's probably way better now. Think about it. It's a passive system, as in you just need to like open it, expose it to air, and 10, 15 minutes, it'll start heating up. I don't know the exact values. I can give you guys the data sheet if you guys really want it. But yeah, and since Zach suggested it, so I feel like this might be the better option. This one, the Kapton heater, we need an active system, so we need a thermocouple, we need more wires, and is that about it?
I mean, if it does identically the same thing, then why go with something that's a little bit more
Complicated.
complicated?
Yeah, I just really like these because how they work.
No, I definitely agree. It's just like if they work the same, and if it's easier, you just throw it in there basically.
Right.
Oh, I just have a question. I'm not like downing it or anything. I just want to like know if you have any knowledge of like the size of it, just to get an idea.
The hand warmers or the heater?
The right one.
This one? This bad boy?
Yeah.
No. I mean, no, I can probably design it right now.
I mean, you don't have it on stat? Kidding?
I have it. I have the links to the website.
No, it's just I noticed it because you have it on the left.
Yeah.
I was just wondering.
Let me see.
Oh, 50%.
I'd be surprised if they actually put the dimensions on there.
Yeah, I was going to say. They look pretty small, so it should be fine.
It's just like they're so small. You just put them in. Like if you're
Yeah,
gonna put
I mean, like-
gloves on, yeah.
Like it shows it in the hand in theory, right?
Yeah.
I'm just like was wondering if they had like a quote unquote official, like so you could model it and put it in just to play around with the size.
Yeah, that's a good point. Oh, right here.
Okay.
Right here.
Oh, what
Oh,
the
perfect. Okay.
10,
Oh,
Is
it
that
pretty
inches?
long.
Yeah. Is that inches or I can't tell?
Yeah, so we
Yeah,
have to
that's
wrap it at
inches.
one point.
Okay.
inches?
Well, these are pretty big.
Yeah, that's 6.75. We'd have to like wrap it kind of on a corner.
Okay.
Well, actually,
Wait, isn't that
That's
like the
bigger.
package?
Yeah,
Or
it's
is
bigger than the box. It's 4
that's
inches,
bigger
right?
than the box, yeah. Because
Wait.
10 inches is 25 centimeters.
No,
Yeah.
no, wait. Go to the picture up there, and then get
It's
to
like the
like the
size of
second
your
picture.
hand. Yes.
Like go to
This
the
picture?
second picture.
Second. Oh, right here. Oh. Good catch, Charles. Oh, it was the whole entire pack.
It's the whole thing.
Okay, this makes more sense now.
Okay, yeah, that's fine then. I mean, that's
Okay.
probably gonna be like half. 2 of those is gonna be like one whole wall, then, right? In
Yeah.
theory.
Wait, how big is Bronco Sat? Like, is it a 3U?
1.5.
Oh, it's okay.
Yeah.
So it's 10 by 10 by like 20
Yeah,
or
something
15?
like that. I can't remember off the top of my head. I'll be honest.
Okay, so I
Yeah.
mean, if it worked, if he did he say like did he actually use it?
Oh, they don't. No, Zach said he was going to use this for his Blade mission last year. Bronco
Oh, he
Sat
did.
is using something like. I'll be honest. I think Bronco Sat's using this exactly, the Kapton heater.
Well, yeah, I mean, it's probably going into space and
Yeah.
you need something active. Makes more
Yeah.
sense.
So I guess for our mission, these seems better. But if you guys have like, any other ones that you guys want to shoot out, feel free to just pop it in here and put it in general, whatever.
Well,
Or
okay,
whatever how Luke wants it.
so he said like he was going to use this on his actual CubeSat mission.
On his actual balloon sat mission.
Well, balloon set, yeah. It's just like I keep going back to like him saying like don't make things too complicated. I just felt like if we just keep adding more and more extra components than we actually need to,
Yeah.
it gets really like not necessary, like really fast or unnecessary.
Yeah, the Kapton heater and the active since it needs an active system to be like, oh, it'll be too complicated.
My question is how like hot does it get?
This bad boy?
No, that one.
This bad boy. Okay, I'll be honest, I don't know. I just took exact word for it. Average temperature is 135 Fahrenheit. Its maximum is 158. Wait.
Okay, then we should be fine.
Yeah.
Yeah, if it keeps it that hot.
Oh wait. I see Andrew pop something. Wait, did Andrew pop something? Oh yeah, he did. Okay. Okay. I'll put it up soon after that. I'll put it up after the battery board. Okay. So moving on from that, the power monitoring system. These are sorry, what are these called?
Like
Yeah,
power
power
bus
monitor. There you go.
or like
Yeah.
a power bus.
Yeah, exactly. Okay, so correct me if I'm wrong. Raspberry Pi is I2C compatible. It's not SPI, and so we can't use SPI. I just put that just because that. So these two are both I2Cs. Okay, my thing is that these two are completely different, but I can't tell how different. I feel like these are used on PCBs when you design it, and these are using, generally speaking, regular like Arduino stuff. So I'm unsure.
I feel like the one in the middle, I feel like they mostly go with, like, aren't they already attached to most like Arduino things? Arduino Unos or something?
Let me check. Yeah, it seems so. So yes, these bad boys right here. So I guess. Oh my god. Yeah, we don't need those. Okay. Yeah, we already have.
Or are
Oh my
they
God.
are they already on the Pico as well?
Yeah, they are.
Are
I just
they?
realized that.
Oh yeah,
My
they're
bad.
on every. They should be on everyone, right? I mean,
Okay.
even the Arduino Nano has it, right?
Yeah. Okay.
Because like how I think of it is because I have my own power supply at home. Like it's in my closet because I used it for my railgun or whatever, whatever that thing was. So I mean, like I'll probably put like 30 volts in on my Arduino Uno, and it won't explode, right? Because it limits how much current it goes through. So I mean, I would imagine it would be on there already.
Yeah. I don't know why. Okay, this was a lot. I was like really tired when I did this, so don't blame me, okay? But okay, I think
excuses.
Okay, I think
No,
this
I'm
makes
kidding.
more sense than this bad boy, this Adafruit bad boy. This makes more sense if you want a power monitor.
Okay.
Yeah.
Yeah, I would. Yeah, I'd probably like. I'd probably have to look at that. Well, I mean, personally, I'd have to look at that more. But
Gotcha.
yeah. But yeah. If anyone has any suggestions, yeah,
Yeah.
I could open the window. It's freaking hot.
And now Luke's gone. We can talk behind his back.
Sorry, what'd you say?
Oh,
Sorry.
nothing.
I
Nothing.
wasn't going for that long, you know.
Okay. So I guess this battery protection IC makes absolutely no sense because it's already on there. But it was fun researching and seeing how they work. So it's fine for me, I suppose. So I guess we don't need these anymore. So, and this is the battery board. I think Andrew sent something to me. Are these a suggestion for the battery board? Oh, okay. What's this?
Yeah, I was just like looking them up, but it seems like we're gonna have to solder stuff either way. Like
Yeah.
that, both the positive and negative output, like you solder onto the board, right?
Yeah.
Like in
Oh,
theory,
sorry.
we
Go ahead.
would. No, I was just thinking, like in theory, could we even make our own as part of like our model, like
What?
add it on?
Make your own Arduino board? Is
No,
that what you're
no,
saying?
no, like the holder. I'm sorry, like the battery board.
No, I'm just kidding. I'm playing with you.
Oh yeah. Okay. So
Like we could just put it into the model itself,
Yeah.
and then solder it up ourselves if we're like really, if we're already gonna have to do it to that extent, finesse it and like be able to like say part of the project we built it or whatever, and customized it.
Hmm. Okay. I was so confused. I looked up at these as the battery board themselves or like whatever. I was looking for, I thought when they meant battery board, I thought they meant this black thing.
Oh,
Okay.
that? Like that
Yeah.
little,
Yeah.
carrying
Little
thing?
capsule. Yeah.
Yeah.
Do we make that ourselves? Like
Yeah,
what
that's what I'm saying.
Andrew
Like
said?
3D
Oh,
print it,
okay.
like or
Yeah.
whatever we need
Okay.
to, like even if it's aluminum, we could attach it somehow, right? But we're already gonna have to solder that board up really to it. So I mean, can we just make the whole model in itself?
Yeah.
I mean, we're still gonna need a battery board, I guess, to some extent. But now I mean, we could decide what that is later.
Yeah, I think we could do that later, as long as we just get a lot of the bigger components that we need in. I think we should be fine.
So it looks like we don't need any battery protection or power monitor in this one too.
Yeah.
Oh my god. Okay.
It's all good
And
though.
I think that's all. Was there anything else we need to trade studies on? Or because the payload it's like pretty set.
I just wanted to clarify some things before we go any further. So like actually the components that we don't need for the system, we don't need any antennas, no solar panels, magnetorquers, reaction wheels, no attitude sensor, GPS. We don't need any of that because this thing isn't going into space. If it was going into space, we need something like we would definitely need some magnetorquers or some reaction wheels to basically what those are is they just stabilize the system. That's all they do. Like yeah, that's all. So we don't need any of that because honestly, we don't need our system to be that stabilized. At least for our like component. If we were taking pictures, that'd be very different. But we could always add like a gyroscope to that. But that's unrelated. We don't really need any sort of control system for that. Solar panels, from what Zach told us, it's totally non-feasible. So we're not even going to consider that. Antennas, we're not even going to consider that either because all of our data is going to be transmitted to the BLV. Attitude sensors, don't need that. That's like for like camera stuff. And then GPS, I think the BLV is going to be doing something, or it's going to have their APRS system, so we don't need that either. That's just that throw something out there. Yeah.
All right, solid. So these are the main ones, right?
Yeah, I think those will.
Main three.
I think. Well, this is just me. I think these are the ones that we'll definitely consider.
Gotcha. I just want to reiterate, does anyone have any suggestions, like if they worked with microcontroller that they prefer or I think will work better than Pico or a battery source or Meteors? I mean, I think this is okay. I don't know.
I think it should be fine. I don't think we need something really super big or super complicated.
That's unfortunate. Just kidding. But yeah.
I did want to say something about the OBC though. I did, when I was taking notes about our meeting we had with the BOV, they said that, because they said that all their components that they're using is going to be like Arduino related. And I don't know if there's like any difference between having like a Raspberry Pi and like an Arduino, if it makes it harder for them to like interlace with each other. So they said like, as long as you guys have Arduino, it's the better it's going to work for us, like in terms of like communication, I guess. That's just what they suggested.
I'm not an EC or anything like that, but I don't think there's an issue because it seems that the Pico or however you want to say it seems to be pretty cross compatible. Like it seems like where was it? Okay, right here. I heard it's like pretty easy to program it and everything, and from that I think it's fine. But if Isabel or Andrew wants to like say something, go ahead. Like, because I have no idea.
Isabella, you got anything?
Wait, never mind. See,
Yeah, I think it's on a what's it called? Like each module is on its own basis. Like I think some are compatible, some are not. So like you'd have to go through each individual thing, if I remember correctly, and like make sure they are. Like Raspberry and Arduino, like since you program your own, I think they are compatible to some extent. But there are some that are just like with the power, like power needs and everything, like requirements. It depends. So I mean, if we get like maybe the BOV's like equipment, or like we get like a list of what they're using, we could maybe go through and check. But
Yeah,
It-
they specifically said that they were going to be using Arduino for this.
no, I like which ones though.
Oh,
Like,
I don't.
What,
I,
that's
I
what it's
don't
like.
know.
What else is involved in their system? Just to make sure, like, if there's two things that are incompatible for whatever reason, that one doesn't burn out or blow up or miscommunicate whatever we need.
wait, Andrew. It says at time of launch there is no Arduino core support for this board. Does that mean it's not compatible at all?
Oh shit.
Wait, I thought it's compatible, or do we know with Raspberry?
I thought so too, but then do you guys see my screen right now?
Yeah.
Like on the Raspberry Pi thing? It says,
Yeah.
what does this mean? It says no core support. Does it mean there is some support then?
I'll be right back.
Because I'm pretty sure that like on the Hyperloop team, we're using Raspberry and it's compatible with Arduino.
Okay, solid. Do you guys? Oh yeah,
Like,
But
like I
I'll
said,
ask.
there's a lot that are, but not all of them are. That's what I meant.
Yeah,
Sorry.
yeah.
Let me
But we need
clarify.
to
Like,
know like which Arduino it is.
that's why, like I was saying, like if we get the BOV breakdown, we can understand which modules or which components they are using of the Arduino system, and make sure they are compatible with Raspberry. Sorry to make that clear. I mean, I'm sure they're gonna be like realistically, it's gonna be like the more complex ones. Part of the Arduino, like you know what I mean, like the real, like the add-on, was it the add-on PCBs or the extra, maybe like Arduino custom thermometer or GPS kind of thing may not be with Raspberry, but we'll have to see.
Yeah, actually, that I've already scheduled another BLV AIRSAT meeting on Friday, so we can ask them.
What time on Friday?
Same time, 7 o'clock. Yeah. So we could definitely ask them there. Yeah, did you have like anything else you wanted to share?
That wraps it up for me. I feel so stupid now for these two.
Oh, dude. Yeah. I was actually looking at that same thing. I'm like, wait, do we need that?
Yeah, because I was working with the Bronco Sat EPS team, and they were mentioning it because they were making their own OBC or flight computer. My bad, flight computer. So I was like, okay, we probably need these too, right? It's like, oh wait, we're not making our own.
Oh, they're actually making their own board. Okay, that's
Yeah, it's
interesting.
called a PolyCube.
Oh, isn't it like taken from inspiration from
PyCube, yeah.
Slow?
Yeah, I believe so. Yeah.
Okay, yeah. Yeah. Before I talk about my thing, yeah, did anyone have any questions about that? Like anything to talk about? Cool. So I guess I'll kind of talk about my thing. So since I'm kind of more in like the technical, I mean, I meant like the material science as far as that goes. So I was looking at different materials on what to use for the CubeSat. I'll share my screen. Oh, that's not even okay. Cool. Wait, is it? Okay, cool. Yeah. Okay, you can see my screen, right? Okay, so I was looking mainly because he suggested that we use. I don't know if is Bronco Sat using aluminum. Do you know, Michael?
For the frame, yeah, they are.
Okay.
Which one? I think it's 661. I'm
Yeah.
not sure. You had asked Ben on that. I'm not sure.
Yeah, it's a pretty high, it's a pretty durable material as far as aluminum goes. Thank God they're not using like 1020 aluminum. That's pretty like really cheap. But that's besides the point. So I was considering between like either aluminum or like the 3D printed as Daniel brought up. I know you're watching this, Daniel. Kind of took your idea. So I was looking between either aluminum and that, and I was thinking like I think aluminum would be a lot more expensive to actually produce because you have to actually buy the aluminum and then you have to weld it and you have to put it all together and frame it and stuff like that. I just feel like that'd be way more expensive. And considering that our mission is like, it's not like game changing, or it's not like going into outer space or anything where it needs to be a lot more durable. I felt like we could be a lot more lenient in terms of like material property. Since well, how are you supposed to hold it together? Well, I mean, you could put screws in.
Bending and riveting.
Well, yeah, you could do that. You could put screws in it. You could thread it. You could do stuff like that.
No, I mean we don't even need that if we just rivet it. Like if we just bend it and then tap it, and we have like a $20 rivet gun from the store, and we just buy a packet of rivets and do it ourselves.
Or you could do that. Yeah.
I mean it's just like welding. Like unless we get someone on campus to do it, it could be decently expensive. Whereas
No,
a
I mean,
pack of like 20 rivets is like maybe $6.
No, for sure. I mean, like, if we were to actually consider welding it, I know how to do it, but like, I'm also considering like how cheap it is to actually make it and ease of like usability and also form factor. So it's not like, again, it's not like this thing is going into space. It's just gonna stay in the atmosphere for like 2 to 3 hours. And considering that we're on a tight budget and that most CubeSats that go into space are pretty damn expensive if you actually do want to launch it into space. Yeah, I think definitely 3D printing is the way to go. In terms of like what like filament to use, I mainly narrowed it down to like ABS or PLA plus, and I found that ABS was pretty garbage. It's a PLA just because of how like it's a lot weaker, and it says it's stronger and stiffer, but when I look at their tensile stress properties, it's like 10 difference. So because I think PLA is like 36.7 and I think sorry, ABS is like 26 or something, so it's not really, it's a big deal. And hopefully our BLV will be able to keep us like from crashing into the dirt. If that's so, then I don't think it'll be really big of a deal. We just need something that's sturdy and like basically won't fall apart. So I think we should definitely 3D print it because it's very easy to like make it. Yeah. And then like the filament we use is PLA plus, not like ABS or anything. And we don't need to go like nylon or anything crazy like that, because that just gets more expensive. And then looking at Amazon for PLA plus, it's about like 20 something bucks per filament thing or whatever. So it's pretty cool. I mean, pretty good, I guess. Oh, you're talking about carbon fiber? Yeah. Did you have anything to say about that, Andrew? I'll just stop talking for a second.
Oh no, sorry. I mean, I didn't interrupt. I didn't mean to interrupt. Sorry. I was watching the meeting. And I think Daniel said something about like support or something, right? Or was I completely off on that?
No, what do you mean?
Like the last meeting, the recording.
No, what do you mean by support? I'm just
I thought
curious.
he talked about like the model and like printing in. No, I'll go back and make sure. Like, sorry, I didn't mean to interrupt.
How dare you? How dare you interrupt me? No, dude, interrupt me at all, anytime. Yeah, it's totally cool. Yeah, I want you to interrupt me. Do it. No, it's cool though. It's cool.
Famous last words.
Right? Interrupt me, and then like as soon as I start saying something, you're just like, oh, wait a minute, excuse me. Yeah, I bet Daniel is just very furious right now. I hope you're watching this, Daniel. But we definitely should use the PC 104 stack because that's just what I guess everybody uses. Even in Blue Dawn, that's what we used. We used the PC 104 stack. It's a lot bigger because it was a 3U. But yeah, that's just for like frame material. I think we should definitely do that because I mean, think about it. Everybody has a 3D printer now. Okay, well, I want to get one. Okay, so that basically means I have one.
Slight difference.
Can you print something right now? So yeah.
You got to get one of those 3D pens.
3D pens?
Yeah, you got to get a 3D pen and make it.
That's not gonna work well.
You don't know that. You would know that unless you had a 3D printer.
I actually did. Look right here. I'm just joking. I don't have one.
Oh yeah, okay. See, look, I
Just
have
get
one.
the Ender 3, bro. $200.
Dang, that looks nice. Well, if you have so many.
I know, right? See, look, I even printed Sparrow from Sparrow the Dragon. Oh no, this is Sparrow the Dragon. See, I printed them out. Yeah, but the Ender Pro 3 actually, my friend has one, and he,
I mean, there's upgrades needed to it, but like, once,
I don't know if
you
I
print out the upgrades. I mean, it's pretty fine.
I don't know
My
if I
old
should...
professor had a, my teacher had a, what's it called? Like, that Lulz bot, the top left, like $2,000 each.
Oh, this one?
No, like the far left one, the very first one, the green one. This shit's so overrated, not gonna lie.
See, my friend has one, and I don't know if I should say this, but he prints.
Is it guns?
Yes, he prints guns. He prints like frames, so he prints like the stocks and things like that.
Okay.
Yeah.
But yeah, like you can get the same quality from like the Ender 3 for 200 than that, which is, as you can see there, 2,500.
Oh yeah.
It's really not worth it.
Well, it probably has a lot. Like what's like its temperature rating as? Because it could probably output a lot more temperature.
Yeah, I think you can technically do more materials with it, but like the quality of the material, you have to like really make sure you like get the printer settings like fine. Like I know he used like a wood filament to print, but he like jacked up the first one because it kind of burnt. Like you have to be really fine with the temperature.
Yeah, and then also the stabilization on the board itself.
Yeah, exactly. Well, actually,
Yeah.
I think that was pretty easy. I think it has a system. Well, you have to get an octo print, and then that is like another few dollars in itself to get that like nice and running. And then it all becomes. Oh, shoot, we're recording this. I can't say that word, but those kinds of words.
I want to really get a metal printer, but they're so expensive.
Oh yeah.
They're crazy expensive. One I saw was going for like $50,000.
Yeah, like it's gonna be another probably 10 years until we can get them like in house.
That would be really cool. Yeah.
I mean, the fiber one is the closest we can get to it right now.
Oh shoot. So before we go off topic,
Sorry.
how dare you to bring this up, even though I brought it up. So yeah, that's just what I found. I think going 3D, have you ever been to the lab for Bronco Sat 1, Jacob, Michael?
Yeah, I was just there earlier today.
Oh, you were? No way.
No, no, it wasn't. No, I haven't been there. It's only a selected few people because you need so much paperwork, and you only have like 2 people in there at one time. So yeah, no.
Yeah, those air quotes.
Oh no, that was accidental.
Accidental air quote. Okay.
Oh wait, that was my other question too. Are we looking to like print it as one piece or like multiple pieces together?
I think we could do multiple pieces because this thing needs to be like easily taken apart.
Okay.
Yeah. So if we just print one whole thing, it's gonna come out really crappy. And then we also need to figure out how to like keep it all together. Which that's not a problem. Yeah, that shouldn't be a problem.
I mean, you can get some pretty decent prints at like a 60-degree. What's it called? No support.
Wait. Okay. So, wait. Do you have a 3D printer?
No, but one of my classes I was a TA for 3D printing, so I had to like print a ton of stuff. And he bought the filament with his own money, so there was no support, or he wanted like as little support as possible. That's why he made me design stuff like one piece.
When you say like no support, what do you mean?
So like basically you would print like an object as one that would be able to move. I mean, sometimes it'd be like 2 or 3 pieces, but it'd be like a good, let's say 6x6 piece, right? That would have almost like maybe like 5 grams of support at max. But if you were just able to angle this stuff and like different curvatures, you could pretty much get it to the point where you don't need any support. It just depends on how you angle it, how you connect it. That's why like you can even make like doors and everything. Like so you can open the box, let's just say.
Oh, I see what you're saying. Yeah.
And like still have it though, so it's not necessarily needing support.
Yeah, I think honestly, we're just going to be printing out each of the the side panels separately. So when we actually go, yeah.
Okay.
So like when we actually go to put it together, we can just slap it on there essentially.
Okay.
And without like, if we actually print the whole frame, then that could be a lot of complications that we run into. Like it deforms in one area or something just because. So yeah.
That's a possibility. I mean, I was just wondering too, because then with screws, I forgot what they're called, but they're like I can't think of the part name right now, but like they're threads. Like you can buy the threads online, right? And so I had another project where I needed a screw, but I printed threads in the thing, right, just to be lazy. But they got I broke the threads. But if you heat up this like the brass or like aluminum thread piece you can buy online, I can't think of the name right now, sorry. But if you heat it up, you can like melt it into the plastic and have it like dried in there, and then you have brand new threads that aren't going to break.
Okay.
Yeah, I'll try to find the stuff online. So like it probably sounds really weird and kind of stupid, but like if I find the stuff, I can show you.
Yeah, no, if you could share that, that'd be like really helpful. Yeah.
Then we don't need to worry about like the connections at any point. We could just melt it into the plastic, make sure it's secure there, and then just easily thread it in with a certified 832 thread.
Okay. Yeah. Yeah. If you find something, just post it in like one of the Discord channels. Yeah. So, because our main intention is to build the whole frame in CAD and then just send that to the printer so it could print it and then we could just like manually thread it or just have the printer do its own thread in it. Yeah, but it's definitely something to consider. But before like we go over our kind of time limit, because I know I wanted to kind of keep this to like 30 to 45 minutes, and I know we're all busy with school and stuff. Did anyone have like anything else to share before like I stop recording, so like it doesn't get too long? Or they just like wanted to bring up? Okay, well that said, I'll stop recording.